So we'll complete off with your Terraform, and then we'll come back to your Jenkins thing. Okay. So as I was telling yesterday, your Terraform, it's your infrastructure as code. So if you want to set up your infrastructure using code, we make use of your Terraform for that. So Terraform is one of the very popular tool that we have in the market right now. It's a very high in demand tool. So any DevOps engineer position you take, you will definitely people will definitely ask you for Terraform. Hey, do you know Terraform? Have you written code in Terraform? Have you managed production environment? So all those sort of things. So Terraform has become a very important expectation. So we've been looking at that. Like I said, I'm not going to go in depth into this, just at a high level, so you can understand. And if you're interested, you can get started with it. So the next thing we will have to do is we'll have to install your Terraform. Now Terraform can be installed anywhere you want, your local machine, any VM, anywhere you want. In my case, I'm using an EC2 instance. So you have documentations available. So let's say install Terraform, and I'm using Ubuntu. So I'll have the instructions. I just have to run those commands, and this will install Terraform for me. So here you can install it on Windows, Mac OS. You can also download the binaries and install it. We are looking at your Linux, and we are looking at Ubuntu. So I just have to run these commands one after the other, and that should install Terraform. So it's very straightforward, nothing fancy about it. Just a set of few commands, and that should install Terraform for us. Okay, so let's quickly complete this. Then let me add the repo. Let me update the machine, and then finally install Terraform. So like I said, it's a very straightforward installation. We just have to run this series of commands, and that should install Terraform for us. And like I said, you can install Terraform anywhere you want, Linux, Windows, Mac OS. Just a moment. Sorry. So I pinged you the link. You can use that to get the instructions, but in my case, the Terraform will be installed. So you can validate whether Terraform is installed or not by, so just a moment. Sorry. So you can use this Terraform -hyphen version, and that will tell you what version of Terraform is installed. Any questions with this?
No, Ravi.
Okay.
No, sir.
Next thing would be your authentication. Depending on where you're creating this infra, AWS, Azure, GCP, anywhere, you will need to authenticate, right? So depending on, so in our case, we are working with AWS. So there are different options that we can use. So if it is your EC2 instance, we can simply make use of an IAM role to give the permissions. And if it is your local machine, let's say, then we can make use of an IAM user. So this IAM user will basically have your access key and secret access. Sorry. Yeah, so you can either make use of these options, either your EC2 instance, which will have your IAM role. And if you're installing it on your local machine, you can create an IAM user, give programmatic access, generate the keys, and you can use this as well. So if you recall AWS CLI, this is what we were doing. So the same thing applies here as well. Okay, so in our case, we'll be looking at this. Just a moment, sorry. Yeah, so like I said, in our case, we'll be using an IAM role. So essentially for this, we'll go to IAM and we can create a role with the necessary permissions. So let's go to roles. Let's create a new role. So this will be for service. So with service, this is going to be for EC2. So here are different options. We're looking at the on-demand. Next, we'll give admin access. So based on what you want your Terraform to, you can define the permissions. In my case, we are giving admin access. So let's give it a name. So let's call this as Terraform role, and we will create this role, and then we will attach this role to your instance. So we'll go back to that instance. We'll go to actions, security, modify, and then select the role. So this should give your instance or your Terraform the necessary permissions to create the infrastructure. Okay. Now, the next thing is writing your code. Okay. Now, generally, when we talk about your Terraform code, it can be divided into different sections. So we have the provider block, we have the resource block, we have variable block, we have data source, we have output block, we have provisioner. So likewise, you have different blocks. Okay, now provider block is used to define your platform. So where do you want to create the infra? AWS, Azure, GCP, where do you want to do? So you define that in a provider block. Resource block is basically where you define the components you want to create. Components to create could be your, like, you want to launch an EC2 instance or an S3 bucket or an IAM user. So what do you want to do? Variable block is like it says declare your variables. Data source can be used to fetch existing resources. Output can be used to display outputs about the resource created, and provisioners can be used to execute scripts or commands on resources. So main sections, but in our case, we'll be looking at some of them. So the first thing we are going to define is, so we are writing this in the YAML language. So first we are going to define our provider block. So provider, we are going to execute this on the AWS, and then your region. So in which region you want to create your resources. So let's say we want to create this in the US East 1. So here you should be able to see the region, right? So US West 2, let's say. Now, depending on how you have done the authentication, if you have used IAM role, you don't have to do anything. If you have used access key and secret key, you will need to provide your authentication. So here in the GitHub repo that I guess I did not share it yesterday, but here this repo, you should be able to find everything, all the examples and references to the Terraform examples. So here, if you see, this is one example that I have. So you can see here profile. So this is, if you see this one, that means we are using access key and secret key for the authentication. So in our case, we are using a role, so we don't need to provide that. Next, we are defining our resource block. So resource is what we use to tell Terraform, hey, I want to create some resource. So what resource you want to create? So I want to create an AWS instance. And then let's call this as example instance. Now you see here, this is Terraform specific. So we have to make sure we use the right resource type. And this is just an local name. This is custom, user defined, you can give whatever you want. And then you need to give the arguments. Now, if you know how to launch an instance manually, this becomes easier. So if you know about instance, we know that we need to give the AMI, we need to give the instance type, we need to give the security groups, the key pairs. So all those details we'll be providing here. Okay, so here if you see, we are giving the instance type. So let's say I want to use t2.micro. Then which AMI you want to use to launch the instance. So let's say we will use this AMI itself. So I'll take this AMI ID. Now, if you're not sure about your Terraform code, it's totally fine. There's a full documentation available for this. So let's say we'll go to your Terraform AWS. So AWS provider, and you'll find the documentation for everything. So we are looking at EC2. So if you scroll, so this is all the AWS services we have. So we are looking at EC2. So there's my EC2. And what do you want to do? So you want to create an elastic IP, you want to launch an instance, you want to create a key pair. Everything is available here. So we are looking at instance. So here you should be able to find the examples. Okay. So another example you can see here, we are creating a VPC. We are creating a subnet. We are creating a network interface. And here we are creating an instance. So the AMI, the instance type. So you have examples available for this, and you can always refer this. And if you scroll down, you should be able to see what all you can pass. So you can see AMI, availability zone, then let's see, instance profile to attach a role, instance type, key name, then monitoring, whether you want to enable detailed monitoring or not, private IP address, your security groups, your subnet ID. So everything that we have been doing manually, everything can be passed, and you can see whether it is mandatory or not. So all these, most of them are optional, but your AMI, let's see, AMI. Okay, that's also optional. Yeah, so based on what you want to pass, you can definitely pass. But like I said, I'm just showing you an example. So this will be our code. So I'll take this code and we'll create a file. Now, all of your Terraform files that you will be creating, it will end with your .tf extension. So we'll create one folder. Let's call this as Terraform. And we'll create a file. Let's call it as main.tf. Now, the name can be anything, but we have to make sure we end it with the .tf, which indicates it's a Terraform file. And we will have our code. So it's a very simple example that I'm showing you here, but the whatever I've shown you over here, you can use this. So all these examples, it's there in my repo, the GitHub repo. You will find all variety of examples. So you should be able to see, creating a custom VPC and launching an instance, passing user data, using provisioners, using workspaces, locking your state files. So everything that you need to know about Terraform, I've covered here. Okay. So there are other examples as well. So here you can see attaching a security group. So if you see here, I have a provider block. I'm launching an instance. I'm creating a new security group, and I'm attaching that security group here. Right. So all varieties of examples are available. Now, let's say you have written your code. Now there is a life cycle that you follow with your Terraform. Okay. So the first time you write your code, we will need to run this Terraform init command. This is the first command that you will execute. Now this will initialize your Terraform config file, the code basically. So what this will do is this will download all the necessary plugins, the dependencies, and all those things will be downloaded. Then we will run the Terraform plan command. Now plan command can be used to do a dry run or visualize your changes. So it's a way to preview your changes before you execute them. So this Terraform plan will tell you what exactly your Terraform will do when I execute them. Once you're okay with this, we will do a Terraform apply, which will execute the code and create the resources. And then we have your Terraform destroy, which is to destroy all the created resources. So this init that you see, we run it only once. The first time when you have return the code, that's when we do it. And this is something that we use very regularly. Okay, so we have the init, plan, apply, and destroy. Let's see an example for that. So like I said, first thing we will have to do is we'll have to run the Terraform init command. So what this will do is, so you can see here, it will try to find the AWS provider, the plugin, and it will start downloading that on the local machine. So what this will do is this will create a folder for us. So this .terraform folder that you see, and here it will download you the provider, which in our case will be AWS. So HashiCorp, and there's my AWS provider. So it will download that. So like I said, you just have to run it once. Post that, we will run the Terraform plan command, which will generate a preview for me. So, so this will be the preview. Okay, so starting from here, so you can see this plus symbol. That means it's going to create some resources for me. What is it going to create? It's going to create an instance. That's the local name. And you can see all the details. So what AMI you have passed, what is the instance type you have passed, and the rest of the things you can see it says known after apply. So here is a summary. So we are adding one resources. We're not changing anything. We're not destroying anything. So if you're okay with this preview, you can go ahead and do a Terraform apply. The Terraform apply will also show you the preview, but then it will ask you for a confirmation. Hey, are you okay to execute this? So you can see, do you want to perform these actions? So typing yes is giving an approval. And when you execute, it will start creating the resources. Now, this is the same error that we have been getting since yesterday. So what I will do is I'll just change my region to US East 1. Let's try that. Okay, so I need to get the right AMI. So this AMI is there in the Oregon region. So I'll need to update that. Hold on a moment, please. Let me switch to North Virginia. And let's take an AMI. Okay, there's the AMI. Let's do a Terraform apply once again. We'll approve this, and this will start creating the instance for me. Like this, you can have whatever infrastructure you want as part of your setup. You can write the Terraform code, and Terraform will start creating those resources for us. So here I should be able to see a new instance getting launched. You can see this instance is coming from Terraform. Obviously the tags will be empty because I've not given any tags, but this is what your Terraform is doing. So you can see the instance ID. So if I take this, you can see there. That's what your Terraform is capable of. Any questions until here?
Yes, Ravi. Ravi, you said Terraform is a multi-cloud, but here in the script, we only gave all the details to AWS related. So I want a script where in launch instances in both AWS and Azure. Is that possible in Terraform?
You can. So you can define multiple provider blocks. So here you can have one more provider block which says GCP.
In the same file, right?
You can, but see, generally what happens is we don't recommend doing this because it becomes very difficult to maintain the code and maintain the infrastructure. It is possible, okay? Not saying it's not possible. You can definitely do it, but you also need to think from a reusability perspective.
Yeah.
Right? You also need to think from a code maintainability perspective.
Okay. So then what is the difference between CloudFormation and Terraform now? Like if it is only related to AWS, so how does it make difference?
So See, now in this case, I can have a separate folder. Okay, so I can maintain a separate folder which will be for, let's say, GCP. Okay, and I can start writing the code for GCP. So I don't have to essentially, I don't have to switch my platform to create the resources.
Okay.
I can do everything from one single place itself. It's
Okay.
all
Makes sense.
doing from two separate folders. That's it. Instead of logging into GCP and doing it and logging into AWS and doing it, we can do it from one single machine itself.
Okay.
Any other questions?
Also, if you make any changes, like, do we get to know that in, like, in the Git? Because any changes to the infrastructure?
In the Git?
Yeah, because if you make changes, like, do we get to know anywhere?
So now let's say you want to use, let's say for example, you change an AMI, or let's say you're changing the instance type. So let's say we'll change this to small. Now, until you don't do a Terraform apply, this will not get executed. Okay. Now, when you do a Terraform apply, this will clearly tell you that, hey, there's a change. Okay. So you can see refreshing the state and you can see, hey, there's a change. So what are we changing for this particular instance? We are changing the instance type from t2.micro to t2.small.
Okay.
And
Got
only
it.
when you approve this, your Terraform will go ahead and make those changes.
Okay.
So yeah, I mean, from a user's perspective, yes, you can definitely, if you're talking about GitHub perspective, you can definitely compare your branches, compare the code, and see what is the change, what new changes are there, and all those things. But again, like I said, unless you don't apply it, the changes will not get executed.
Okay. Got it, Ravi.
Any other questions?
No, Ravi.
Okay, now at any point, if you want to destroy the resources that you have created, like imagine you have one VPC, you have one S3 bucket, you have one IAM role, you have one EC2 instance, you have one database. So many resources. I just need to run this command. Again, this will show me a plan. It will ask me for the approval. If I'm okay with it, I'll approve it. And Terraform will start destroying, meaning it will start terminating those resources. So you can see one to destroy, and this is your preview. So you can see the instance ID. It will destroy that. So if I approve this, it will go ahead and destroy that resources for me.
So here, like, let's say, like, you have given me access, and then, like, I'm not the admin. So if I destroy, so it will get destroyed, right?
Yes.
Okay, everything is being controlled via, like, IAM role.
Yes, permissions and everything is being provided by your IAM role in this case. Yes.
Okay.
So essentially, what we do is we don't encourage people executing Terraform from the local machine, and we always put in an approval process. Okay, to avoid these kind of situations wherein someone accidentally destroys the resources, right? So you make your changes, but then to execute it, you'll need to get an approval. So there will always be an extra pair of eyes to review those changes. And if it's okay, then we go ahead and approve it so that you can apply those changes. Make sense?
Yes, Ravi.
Once we destroy that, we cannot get those resources back. So
Again, you'll have to apply it.
okay,
But whatever the data, everything will be lost unless you have not taken backups.
okay, okay.
So like I said, the Terraform files are saved with your extension .tf extension. And it generally has two main components. One is your block type and then your key value pair. So this the first line that you see, we call that as your block type. As to what is the type of block. So in this case, it's a resource block. So resource type and then your local name, and then it follows your key pair. So this will be your key and this will be your value. So that's basically how your Terraform code is written. And then I just showed you an example. And like I said, let's say if you're curious about VPC, so here, it's not necessary that you have to write all the code in one single file. You can divide it as well. So in this case, if you see, my VPC is written in this file. So I'm creating a VPC, and if you see here, I'm using var. Well, that means I've declared variables. So where are my variables? So here you will see this file vars variables.tf. This is where I've declared everything. So my CIDR range, my instance tenancy, my tags, my public subnet, private subnet, all the details I've declared in the variables. Then we have my internet gateway, the private route table, the private subnet. So everything that we need as part of your VPC, we have declared here. This is my instance. So we're launching an instance. You can see again, we are making use of your variables and everything. So when I execute this code, this entire code, this will create a custom VPC for me with all the subnets, the route tables, the security groups and everything. Launch an instance in that VPC for me. Make sense?
Yes, Ravi.
Yes, sir.
And here is an example for attaching an existing role. So again, here I've declared my provider block. Here's my main block. So you can see this instance profile. So I'm using this data source block. So data source is used to fetch existing resources. So I'm telling that, hey, there's already a role available in AWS. Just get that role and attach it to my instance. The value for everything is declared in my variable. So this one. And the value for this is available here. So, I mean, Terraform is really a good tool, but you also have to be careful. There are certain limitations with your Terraform as well. Like, this destroy thing. If, accidentally you do something, it's gone. You won't get it back unless you have backups of your data. So you have to be extra careful when you're working with this. Questions?
No, Ravi.
In that case, I'm gonna stop here. Sorry, I'm a little under the weather. The cold is pretty bad. So I guess the Jenkins master slave is still pending. I'm still having that issue with my account. So we'll have to wait until that is resolved. So in the meantime, what we will do is, yeah, I guess I will not be able to show an example for Kubernetes as well because I need two instances. Let's see. In that case, will maybe I can get started with your Kubernetes. So we have two tools pending: Kubernetes and your monitoring tool. So monitoring, we'll be looking at your Grafana and Prometheus. So hopefully by next week we should be able to finish off everything. Okay.
Okay, Ravi.
Okay.
Okay. In that case, thank you so much, and I'll see you guys tomorrow.
Thank you, sir.
Take care, Ravi. Thank you.
Bye.